Today we have check if array is sorted and rotated. This is marked as easy. However, um, it's pretty tricky to get a better working solution than O of n, like big notation time. Um, it says given an array nums, return true if the array was originally sorted in non-decreasing order, then rotated some number of positions. Otherwise, return false. So basically, we have an array. Rotated means the starting index originally moved from 0 to some number of x times. So, like, it starts from here now. So basically, the array goes 1, 2, 3, 4, 5. Has been rotated. That's what he means. There may be duplicates in the array. It says an array rotated by x positions results in. That's just what I literally explained. Where I plus x, where modulo the length, where so basically if it goes here in the index here, it starts all over again. It's a cycle basically. How that's done is done by moduling. So basically the length here is 1, 2, 3 is 5. If we go to 6, we go to 6 module 5, which is going to be 1 again. So that's how we get a cycle. Anyways, I'm pretty sure due to these constraints, a double loop would work, where you just double loop and try to. I didn't really solve it that way, but I guess that's why it's easy. However, the solution I came up with is pretty weird, but it works, and it actually got accepted. So let's dive in. My idea was basically find the like the minimum value of the array, and take that as a starting point. Basically, find 1, and then from 1 and a normal iteration till 1 again would probably be sorted if it's the best case scenario, right? That was the plan basically. So basically the main plan here was finding the index of the smallest number, in our case 1, and then I'll get to this later because this was just an edge. It was an annoying edge case that I had to. Anyways, let's just skip this for now, and then all I do is I just have this temp where it starts from 2, and then it just keeps iterating until it reaches 1, basically, because I don't want it to reach 1 again. So basically what happens is I compare these two, and then I compare this with this, and then I compare these two, and then I compare these two. Yeah, eventually that's what I'm trying to do. So basically temp starts from min index plus 1, which is basically this, and then it looks behind it, so it looks at the 1, it's all good, it's sorted, and then it goes to 3, looks at the 2, sorted, goes to 4, looks at the 3, goes to 5, looks at the 4, and then it goes to 1. And I don't care about looking at the 5 here. I don't care because that means it's sorted anyways. So if I find any thing abnormal where, for example, I'm looking at the 1 here, and it's like if nums temp less than nums temp minus 1, return false. If I'm smaller than this should be increasing, because it says non-decreasing order, which is increasing orders. So basically I return false, and then I just increment and modulo by the length of the array, right? So if you submit this without this part, it's gonna pass until, but it's gonna give you like one, like there's gonna be three, probably one. There's gonna be one test case that doesn't pass, which is, let me actually show you guys. If I submit, right, there's this weird test case that goes against the algorithm where I basically choose the first occurrence of that smaller number, right? In case it's 1, 1, 1, 2, 3, whatever. So I choose the first one. But here, it's actually better to choose the last one, because if it starts here, it goes 6 and then 6, which is the same, and then 10, so it's sorted. But if it starts here, it goes 6, 10, and then 6 again, which is broken, right? So I just have to handle this edge case where they're the same, the beginning and the end are the same. I have to get the first occurrence from the last part of the array. So basically, let's say if I copy this, let's say this is not like this. Let's say this is like another 6, another 6, another 6, right? I have to get this 6, basically. It's just an edge case where the starting and ending points are the same. I have to get this 6. So that's what this part is for, where it just loops backwards until it finds the first starting point of that number and then breaks, and then I just reuse it. So if I submit that again, it passes as you see. Time complexity is O of n. Yeah, thank you guys for watching. See you in the next one.